Let's take a look at this problem square of sorted array. Given an integer array nums, sorted in a non-decreasing, that is ascending order, return an array of the squares of each numbers also sorted in the ascending order. We are given something like this in ascending order. Take square of each number and the result should also be in ascending order. A very trivial solution of this problem can be just take a square of every number in place and sort them using a inbuilt function. But as we can see over here, can we find this in O of n time complexity? Because sorting would be minimum n log n. Can we solve that in O of n, which means in one traversal of the array, can we solve it? So to solve this problem, we can observe something about squaring of a number. If a number is -4, -1, 1, 4, when we square a number, negative has no meaning. It becomes a positive, which means we can see these numbers as their absolute by removing their negatives and consider them on their absolute values only. Which means if we take this example, the -4 and 10 would be judged on their absolute values, not on their sign. So what we can do is we can create a result array over here. We can look at these two numbers and say, okay, which one is more in absolute terms? The number that is more goes to the right. The number that is smaller goes to the left. Between the two of these, 10 is bigger. So the square of 10 can be stored in result from last to first. Once we have stored 10, let's move this pointer next to 3. We need to compare -4 and 3, their absolute values. We can say that -4, absolute 4 would be larger than 3. So we can take the square of that and store it 16. Once we are done with -4, we can move this pointer forward to -1. Comparing -1 and 3, 3 has a higher absolute value. We store 9. Once we are done with 3, let's move the pointer forward. Between 1 and 0, 1 has a higher absolute value. We would store their square. And in the end, we are only left, we can move this pointer over here, which is the same object. In the end, 0 is 0. So we can just take the square of 0. And in this way, in just one pass, using these two pointers, we can solve this problem. Now let's take a look at the code implementation of this problem. So I am here in the code editor. I would like to create a list to store my result. The result, I would initialize it to 0 and its length would be length of nums. Next, I would like to create two pointers, one pointing to the beginning of the nums and the other pointing to the end. Left equals to 0, right equals to the length of nums minus 1. Then I want to traverse through result and fill it up. The left and the right pointer would be moved based on the conditions. So also I want to move from the right in the result to the left because we want to store the larger value first. So for I in range, I can say from the end, which means length of nums minus 1 until -1 in Python. This would go from n minus 1 to 0. After that, I can do the absolute comparison. So if the absolute value of the number at left, if this is larger than the absolute value of the number at the right position, I would consider left in my solution. So I can say square would be equals to nums left square, and I can append this to the result. So result I would be equals to the square. I don't really have to use square over here, so I would just use this directly. I will remove this, and once I'm done with results, I can say that okay, I took the left value. Let's move left forward by 1. Otherwise, if the above condition is not true, let's do the same for the right value, which means result at I would be equals to nums at right, and we would just square, and right plus equals to 1. We would okay, right would move backward, so minus equals to 1. Once we are done with this, we can return the result back from the function. Let's try to run this code. Let's submit it. We have a solution.